Hey guys, welcome back. So far we have had a lot of discussion on big data. We have seen some general aspects and we have seen the applications of big data. We have seen its importance in the industry. We have seen why we should be learning big data and some facts and figures which determine that big data problem is going to increase in the near coming future and it is going to produce more and more jobs. We also had a discussion that why technologies like Hadoop or why this framework like Hadoop is going to stay there for a longer period. Now let's have a summarizing session wherein we'll go through some slides and just brief on or just try to wrap up things with some technical definitions that we have available in the market. We have already prepared our own stuff and assume that by today you're already in a position to say that okay, I understand big data and I can define big data in my own ways. But now let's have a look at some of the available definitions of big data, and in the later part of this video let's try to analyze that what happened with the typical distributed systems exactly, or what were the minor problems in the typical distributed systems that got highlighted when these systems were exposed to the big data. So starting up with some formal definitions of big data, then what we have is big data is the amount of data that is beyond the storage and processing capabilities of a single physical machine. Big data is data whose scale, diversity, and complexity require new architecture, techniques, algorithms, and analytics to manage it and extract value and hidden knowledge from it. Every day we create around 2.5 Clinton bytes of data, so much that 90% of the data in the world today has been created in the last 2 years alone. This data comes from everywhere. It may come from sensors used to gather climate information, post to social media sites, digital pictures and videos, purchase transaction records, cell phone GPS signals to name a few. And this data is called as your big data. If you talk about the characteristics of big data, then we have already seen that big data can be defined with the help of three V's, which is your volume, variety, and velocity. So for a data to be referred as big data, generally the volume of the data has to be massive. The data would be semi-structured and may originate from variety of sources and in variety of formats, and the rate at which it comes into the system is really very fast. So now, big data is kind of clear. So now let's go ahead and try to visualize it in some couple of points. So if I try to visualize big data, then big data will look anything like what these kind of a systems generate. It can be anything what your social medias generate. It can be stuff like your emails. It can be the data which your email websites or mobile apps generate. It can be images like you get on websites like Flickr or Instagram. It can be your video streaming. It can be your e-commerce transactions, or it can be the data that search engines like Google generate. What do we exactly do with this big data? So far we have seen that okay, we try to find the analysis like sentiments of the people, we try to do some brand promotions, we try to calculate some samples so that we can reach decisions on the stock market prices, we do some analysis so that we can find the climate conditions and everything. So what exactly we do with this data is nothing but we play around with it to generate some graphs and some charts. Basically I can say that as reports. So what we simply do is we analyze this big data so that we are in a position to generate some reports which are market strategies or people who work on these graphs and stuff can go ahead and utilize it for doing some brand promotions. Again, why is this necessary for us to do all this? What are we actually going to get from doing all this? So what we are going to get from doing all this is the most important thing, that we can understand our customer in a better way and we can influence the behavior of our customer. So this is what, this is like a summary of whatever we discussed in the earlier videos. Now let's try to have a look at what were the problems with the typical distributed systems that got highlighted when they were exposed to big data, and why we exactly felt the need of new distributed architectures like your Hadoop. So the typical distributed systems have had an architecture similar to somewhat like this, that they had some application servers connected to each other and running in coordination with each other. And they had the storage area network, which was a centralized storage. And all these guys had a rigid connection or a strong bond between each other. Suppose if application server So all the data used to reside inside your storage area network. And suppose if application server wants to calculate what is a plus b is equal to, so what he has to do is he has to travel through the network, reach the storage area network, and get the information from there that a is nothing but 3 and b is nothing but 4, go back to his own place and say that a plus b is nothing but 3 plus 4, which is equal to 7. And once it has generated the output, it has to come back to the storage area network, traveling across the network again, and store the result there saying that a plus b is nothing but equal to 7. So if you talk about this overall functioning of this typical distributed system, that what we have is that every application server does some processing, and for doing every processing what it requires is data. So whenever it requires any data or produces any data, it has to travel through the network and store it or fetch it from the storage area network, which is nothing but a centralized storage. So keeping these things in mind, they had some problems with them. Keeping all these things into picture, they had some problems in them. Out of these, some problems which seriously got highlighted when these systems were exposed to big data were these: network dependency. So as we have already seen, every time you want to do any processing, may it be a small processing like a plus b, but you have to again and again travel through the network. So the network dependency is really very huge. Scaling problems. Scaling means scaling up or scaling down, means adding more resources or removing more resources. So because all these systems were rigid connected, were having a rigid connection between each other, it was really difficult to add new systems or remove some of the existing systems. For example, if you have 10 people and all these 10 people are working on one website, then there would be a problem if couple of people don't show up. And even if I add a couple of people in the team, then again there would be a problem of distributing the work on which already 10 people were working. So there comes the problem of knowledge transfer. Then there comes a problem of analyzing that what is done so far and what can be distributed to these guys, and then training them that okay, this is what you have to done. So the scaling becomes a problem if you work on the same thing. And there in the typical distributed systems, they were working on the same data. There was only one centralized storage on which they were working, and so it was a real problem for to scale up or to scale down. Talking about one more problem, the partial failures. Suppose if application server wants to calculate a plus b is equals to c, and application server 2 is calculating c plus d is equals to answer. So as long as application server 1 completes its operation, application server 2 cannot proceed. So if in this case application server 1 fails, then it creates a huge impact on application server 2 because it will never get the value of c. Similarly, if I talk about LAN in my school laboratory or college laboratory or even in your offices, then what they do is if suppose one of the systems goes down, then you have to make sure that what's exactly gone wrong, which is the link that is broken. And if I talk about 10,000 or more than that machines connected to each other, then finding out the broken link really becomes very difficult. And this is the reason why partial failures were very difficult to handle if I talk about the typical distributed architectures. Then again, this data was transported here and there. So every time somebody has to do any operations, it has to take the data from somewhere or dump it to somewhere. So the major focus was always on transporting the data. So this transportation was very good. See, if there are 10 people who are traveling every day here and there, then that's good. That's kind of manageable. But if there are 1,000 and 10,000 people traveling here and there every now and then it becomes a real hectic problem to manage this kind of a transportation. So as long as the data was data, it was easy to transport. But when data became big data, it was having serious troubles and serious problems in the transportation part. Then comes one more issue, which is data synchronization. So whenever you have any system that, if you have more than one system using the same data or working on the same data, then you always have the problem of data synchronization. For example, if application server 2 is looking for the value of CS5 and application server 1 has already made the changes and did the, modified the value of CS7, and if application server 2 is not aware of that, it may finally end up taking the value of CS7 and it may produce a different result as expected. from what was expected. So to avoid these problems, the data synchronization was also necessary. But again, data synchronization was good enough and easily manageable as long as the data was only data. But when again the data became big data, then there were serious threats and serious problems in managing this. And because of these problems, what felt was that we should be having some system which is more reliable, more efficient, and which can eradicate all these five problems, and which can enable us to work with this big data in a distributed fashion, of course, but in a more efficient way. And there comes your hero, there comes your big data solution, which is your Hadoop. So this was a quick session, guys. And in this session, we just wrapped up everything and saw the problems with the typical distributed systems. So this would be it for this particular video. And from the next video, we'll actually jump into Hadoop and see the entire architecture of Hadoop along with its job process and some of the important components. So stay tuned and keep learning.